Hello everybody, thanks very much for coming. I hope you're not too tired after all this day of talks. Today we're going to talk about how to design an open social application for speed and scale. And I'm using some slides from my friends Arne, Roman Kurik, and Chris Chabot, who gave this talk at Google I/O last week, or 2 weeks ago. So my name is Patrick Shanezon. I'm a developer advocate with Google. I've been doing lots of APIs, AdWords, Checkout, OpenSocial, and now Open Web technologies. So, success in a social market. How do you build a successful social application? The CPM, or cost per mil, which means what advertisers pay for 1,000 impressions on your page, on your application in this case, is quite lower than average in social networks. Because of that, that means you need to have lots of users in order to make money with your application. On the other hand, on social networks have viral features, and that gives access to for your application to millions of users and potentially very quickly. If your application gets viral, if friends are sharing it, then you get many users very fast. So essentially the equation for making money in social network is you have a small margin, a low eCPM, and you multiply that by lots of users. What that means is that small tweaks to your application really matters even more than in a regular web application. So coding for performance is very important. I am going to speak quite slowly during this session. We had a discussion with the translators just before, and because there are lots of technical terms, I want to let them the time to translate it for you. So these are a few quotes to explain why it's important to think about performance when you're building a social application. So this one is from Marissa Myers, who's the VP of Product Development at Google. Improving our latency is really, really important, and so important that if we add 0.5 seconds, which is 500 milliseconds of latency, to the google.com homepage, it costs Google 20% in search traffic. So that's a lot of, potentially a lot of money. Amazon has exactly the same experience. So Amazon, they're selling a lot of things. They're in e-commerce. And this is a quote from Greg Linden. And even very small delays would result in substantial and costly drops in revenue. So what's good about developing web application is that you can measure all that. So 0.1 second, which is 100 milliseconds, cost Amazon 1% of sales. You can look at their financial report to understand what that represents. Marissa Myers again, when you make a product faster, you get a lot back in terms of increased usage. So when we remove 30 kilobytes to Google Maps, there's been 30% growth in 3 weeks. So that means that making your application smaller in terms of volume of file downloaded by the client can be really a successful strategy. And then I'd like to continue, and this is just for you guys in Japan. I'm a big fan of Zen Buddhism, and especially Zen koans. So one of my favorites is part of Mumonkan, and it's a monk who has Joshu. So in the original story, he asks whether a dog has Buddha nature. So here he will ask, will my web application have Buddha nature if I optimize for speed or for the number of features? There's always this dichotomy when you're creating a web application between should I just create some features or optimize my application? As many of you may know, the answer of Joshu was mu, which means nothing, or nor yes nor no. essentially, you have to code your features, but think also about performance. It's really a very important aspect of your social application. So in this presentation, what we're going to do is to measure the impact of changes on large-scale apps. So we're going to take a sample OpenSocial application that we've coded in a very naive way. And then I'll show you how, by applying different strategies, how much do we save in terms of latency, in terms of cost. And we'll show you some real performance numbers that we measured on this application after applying all these optimizations. So we have a naive version of it, and then we have a completely optimized version of it. So the goal is to deliver a fast user experience, to minimize the cost of running a social application. When you're a developer and you put a social application out there, you're paying for your hosting cost and bandwidth cost, and that's not trivial when you start to get lots of users. And then we're going to highlight a few new features in OpenSocial 0.9. I don't know if any of you went to the other OpenSocial talk. There are lots of features in OpenSocial 0.9 that help you optimize the performance of your application. So I'd like you to know about them. So I'm going to introduce you to Quartermile, an application that was created by Arne Roman Kurek, one of my colleagues in the Google Developer Program. It's an application that I'm going to show you a demo. Or actually, he's showing you a demo here in the video. So Quartermile is an application that lets you share with your friends some runs that you're doing, whether you're biking or whether you're jogging. So you can say, I jogged for 5 minutes and all that. But instead of doing that by yourself and just sharing that with your friends, you participate into teams. So you create teams of runners in order to motivate yourself. So then you invite some of your friends to these teams. So here we're sending a message to some of our friends. That's a social part of the application. And then I can say, OK, I walked for 1 mile yesterday. And then my friends in the same team are going to record their jogs as well. And each of us will have access to a list of updates here. And then some stats there about how our team is doing. So you can see how the updates are made here on this side, and how for each day we see how the various players in that team ran. And then we can benchmark individual performance. The goal of this application, it's kind of a fun application to oblige you to exercise every day and to apply peer pressure on yourself. So I'm going to, So how is Quartermile built? So on the back end, it's built on Google App Engine. Google App Engine is a cloud computing platform of Google, where we expose some of the services that we use to create Google applications to external developers. There's one version in Python and one version in Java. And then it's using remote procedure calls from the gadget back to App Engine to just get access to all the data about the things that people have run and all that. And all the data is serialized using JSON, JavaScript Object Notation. On the front end, we have a gadget. We have gadgets that target multiple containers, so we can deploy our application on MySpace, Orkut, but also Mixi in Japan. And then we're using a JavaScript library for RPC calls. So you can view the source of Quartermile at this URL and get the XML specification for it if you want to add it in your container. If you want to add it in the Orkut sandbox, for example, you can get the XML for it there to play with it. And to look at the code, you can view the source there. It's an open source project. So I highly recommend that you do that. These slides will be made available on the GDD website. I'm also going to post them on SlideShare tonight, so you can have access to all these URLs. So how do we measure quarter mile, and what do we measure exactly? There are three types of things that we're going to measure here. The first one is the quarter mile API calls. So quarter mile API calls are the calls we're making from the gadget to our App Engine backend for application-specific data. So we're going to measure the latency of these calls and the volume. Then we have the OpenSocial API calls. So in the gadget, we're making all these calls to get the list of friends, get the list of members of our teams, maybe get some profile information from them to get their picture or their display name. So we make these OpenSocial API calls. And then the gadget itself is a user interface, and there are some assets in there that are downloaded. The JavaScript, images, some cascading style sheets. All these take time to go from the server to your browser, and we're going to measure that. What kind of metrics are we going to take a look at? Bandwidth per page view. So how many kilobytes per page view do people download? Number of requests per page views. That's a very important aspect as well. The latency in milliseconds per page view, and CPU time on the server side. So it's important to measure each of them individually because they will affect the perceived performance by the end user of your app speed. And on some of them, you have more control than on others. And as I will show you, on some of them, you can really drastically improve these metrics. So this is the measurement for the naive implementation of quarter mile. Naive means we're just using OpenSocial 0.8. We don't do any optimization. We don't apply any optimization best practices. This is kind of your baseline, when you just implement the feature without thinking about performance. So here we have 4 kilobytes per page view in terms of quarter mile API calls. We have 4 requests per page view and 2 social requests. We have 6 seconds of latency. That's quite big. And 2078 megacycles of CPU per request. Social requests, so we have the data there about the latency and all that. And for these, the assets are the CSS, the JavaScript, and the images. So that's kind of our baseline on which we want to improve. But you can see that 6.4 seconds, when you load a page and you wait for that long, it kind of feels long. Now, we looked at the latency and the metrics that the user sees, but there's another aspect to this, which is how much does it cost to you to expose this application to users? So here we can see the speed. So we have the latency of the gadget and the latency of the whole page, the social networking page where this gadget is embedded. The total number of requests, and Y-Slow, or Yahoo Slow, is a Firefox add-on that gives you an overall score about how your page is performing. Our score is 72 here. But we look also, in addition to the speed, we are looking at the cost. So here we're hosting it on App Engine. On App Engine, you have 5 million page views per month. In free everything, free processing, bandwidth, and all that. But after that, you need to pay per usage. And so here, we're looking at the dollar per month value that your app is going to cost for 11 query per second going to your application during a month. So when you multiply all these numbers, you get 5 terabytes of data in bandwidth. The cost is 0.12 per gigabyte, so that's $670,100. So to get it in yen, you have to multiply by 100. So that's approximately 67,000 yens. And then the CPU time costs you 185. So the total cost to serve 11 queries per second for a month is $855 approximately. And that's what we need to improve. So first, the first thing to do to improve these metrics is just to apply some classic web development best practices. And the thing is, your app is a gadget, but gadgets are web apps too. They are rendered in the browser. They use the same technology that you use to build a web application. So you can apply the same kind of optimization that you apply to optimize a web application. Related to that, I highly recommend that you go watch the video of the Google I/O session by Steve Souders or read his book. He wrote a great book about 10 or 11 tips to optimize the performance of your web application. These tips will apply very well to gadgets as well. And actually, we're going to see several of them here. So we're interested in application size, request count, and latency of the initial load. And we're going to use some measuring tools. So there are three classic tools. In Safari, there's a tool called the Web Inspector that allows you to see a lot of things about your application. In Firefox, there is Firebug and YSlow, which are Firefox add-on that you can use to measure a lot of things about your application and to debug it as well. And in Internet Explorer, there's a tool called HTTP Watch. So whatever the browser is, just use one of these tools to see what's happening. So the first best practice is to minify your JavaScript and CSS. The idea is that in JavaScript, as in CSS, there's a lot of characters like white spaces or carriage return that are useless to the browser who interprets the code, but that are very useful for the developer who creates the code. So the code that you see here can be minified to the code below there. Sure, for a developer, the code below is not very readable, but for a browser interpreting it, it will be the same thing. So it's really good to just minify your JavaScript like this. So when you look at the size of when you look at an application that you loaded into a web page, if you use the Safari Inspector, here you can see what is the size of the various files that were fetched by the browser to make your application come live. And when you minify your JavaScript, you can see that these files get much smaller. So here, for example, what you can see is that jQuery, which is a classic JavaScript library that people use to develop web applications. Here we use jQuery 132.min.js, and min means minified. So when you do JavaScript and CSS minification, you get 54% saving in terms of the size of the request. So that represents a saving of $61 in terms of money. So that's quite significant. In order to minify our JavaScript here, we use the YUI compressor. YUI is the Yahoo UI tools. Yahoo has a very good library of widgets called YUI. And as part of this library of widgets that are open source, they also have a compressor that most developers are using as part of their build process to just process their JavaScript files before pushing them to production. So how do you measure latency? You just use one of these tools, whether YSlow or Firebug or the Safari Explorer that we see here. And in there, you can see these bars. The Explorer shows you how the requests of the various files are serialized and how much they take. So here we can see that it took like 1.62 seconds to download the main file from the browser. And then there's been 4 files who were downloaded in parallel. You can see these files there, all the JavaScript files. The problem with latency is that so you're in a specific place and you measure the latency of your app and you say, okay, I'm done, I'm finished, I measured latency. It's more complicated than that. Latency is not a static number. It depends on how many people are hitting your application at the same time. And it also depends on where you are and what time of the day it is. So this is a Google Analytics view on latency. So you can see that latency can be different in very different countries at the same time. And it varies with time as well. So what's important is to measure from different locations and measure often. So if you want to record, if you want to do these measurements of latency, you can use code like this. So here, this is JavaScript code that you will put in your gadget. So here, you create a new date that measures the start, so that's the start time. So that's now. And then you create a new image element and on load, which means once the image element will be loaded, you pass a function, and the function defines an end time variable. So end time is the moment when the image element was loaded by the browser. And then you say latency equals end time.getTime minus start time.getTime. So you'll get the amount of seconds that happen between the moment when your script was executed and the moment when the image was loaded. And once that has happened, you just make a callback to your server using either make request or using JSON RPC. Another best practice is to sprite images. So spriting images is a classic technique where you concatenate all the images that are used in your application into one single big image. That's the one you see on the right here. Spriting works really well because while the volume of data that your browser is going to download is the same, making some HTTP request calls is quite expensive. So you have to initiate the socket connection, you have to send some headers. For small images, sometimes the size of the headers are as big as the image itself or half the size. And if you have, like, let's say, 200 of these images in there in your application, first, some of these HTTP calls will be serialized, so they will happen one after the other. Usually, the browser keeps only like 2 or 3 open HTTP connections at a time. So here, what you're doing is that you're doing only one fetch. The headers will be only for this one fetch, and that's it. And then you cache the image on the client side. And then how do you use that on the client side? You use some CSS tricks to say, oh, here in this place, I wanted my image 1. And my image 1, with CSS, I just hide all the rest except for image 1, and I position it in the right place. So if you look at many websites, they're using this technique, and it's a very effective technique to minimize your latency. One last tip is that there are some tools that help you create this sprited image and will generate the CSS for you. If you go look at the Google I/O session by my colleague Ben Lisbakken about advanced JavaScript techniques, he mentioned some of these. Google Web Toolkit also allows you to generate all this. Google Web Toolkit will generate the sprited images for you. So another thing is you want to determine how many requests happen from your application. So why slow tells you that. It tells you, OK, there's been 20 HTTP requests, and the total weight was this, and this number of requests were taken from cache, and the other were just fetched from the site. So it gives you some pretty good statistics. So after we do image spriting, what kind of improvement do we get? So first, we reduce the latency by 45%, reduce the size by 39%, and we reduce the number of requests from 15. So we were requesting 15 images, and here we just do one request out for the big sprited image. So number of requests goes down by 93%. In terms of dollar savings, it's like, I would say 1/3 between naive, which is at 27, and we're going, no, actually we do -10, so it's 1/3. You save 33% this way in terms of money. Spriting is assembling all these images together. Palette fixing is looking at the colors and changing the way the colors are encoded in your image to remove all the redundancies in there. So it's equivalent of what you would do in GIMP or in Adobe Photoshop when you save an image for the web, and usually it reduces the size of the image. So that gives you some good savings as well. Another web development best practice is to adjust the cache headers. So you want the browser to use as much files from its local cache as possible in order to make less requests out there. So you can do that by adjusting your, for example, if you're using Apache, this is what the configuration would look like. You say for files that are static, like CSS, JavaScript, GIF, PNGs, and JPEGs, I'm setting the cache control to max age, like a very big number. That means in the very far future, you can get rid of your cache, but you're going to cache that forever, essentially. So you tell the browser, just keep that file forever. I don't want you to ever fetch it again. But then you tell me, I'm going to modify all these files, so how do I force the browser to get them again? In order to do that, you use some cache busting techniques where you just add some parameters like $v=3 with the version number here. So in your app, just specify what the version number is in a central point, and then all the assets that you're getting are for that version number, and that means that at that time, if you bump up the version number, the browser will get the new version. There are also some server-assisted optimizations that you can do. So for a social gadget, a small tweak can be a big gain. But for a social gadget in a social network, many small tweaks can be very big gains. The advantage here that social networks have over the developer is that social networks control all the HTML that they output. Your OpenSocial application is an XML file that is fetched by the social network and cached and can be eventually manipulated. It can rewrite it, it can do some optimizations in there. So social networks typically can absorb some of the traffic that users fetching your files have, and they can absorb it for you. So social networks typically use what is called CDNs, content delivery networks, like Akamai, for example, that allows them, if I'm a user in Japan and I fetch this page for an application that was developed in the US, I will be served the file from a Japanese server of Akamai, and the social network doesn't have to worry about this. Akamai does it for them. So these are what CDNs are doing. And so that means the latency will be much smaller. But as an application developer, you won't pay for a CDN by yourself. So the way you use that as a developer is that instead of just getting some URLs from your server, you use an API call called gadgets.io.getProxyURL. So this call is part of the gadgets namespace. It's kind of it's a namespace that's for non-OpenSocial stuff in gadgets that are necessary. And so getProxyURL, what happens when you use that is that the social network then is going to fetch that file and going to and the CDN of the social network is going to serve that file instead of that file being served by you. You can also do content rewriting. So there are a bunch of things that you can do in a web application in order for it to load faster. So for example, you put the CSS first and the JavaScript last. So that's well explained in Steve Souders' book if you want the details. Concatenate and minify the JavaScript, rewrite the URL for static proxy. You can ask the server, the social network server, to do all that for you. So if you want that to happen, as part of your gadget in the module prefs, you have an option. You say, I want the feature content rewrite. That's an optional feature. And if this feature is there, I want to include some URLs and exclude some URLs and include some tags. So you specify how you want what kind of optimization you want the server to apply to what URLs on your side. So what we saw before was just like general web application best practices and gadget best practices. Now we're going to go really into the OpenSocial specific best practices. So OpenSocial offers some conveniences to social app developers. So when you design your own application interfaces, just look at how OpenSocial does it, because there's been a lot of work put into how the API is designed so that we can do all these performance optimizations on the server side. And if you're interested in the server-side optimization, you can take a look at the Shindig code base. Shindig is the server-side implementation of OpenSocial, and in there, there's a ton of optimizations as well. So batching is the first one. This is an example of, here you use, we're making several consecutive calls to OpenSocial. First to get the viewer, and then to get the owner. So the viewer is the person who's looking at the application. The owner is the person who has installed the application on their homepage. And then I get the friends of the viewer and the friends of the owner. When I execute these 4 statements, each of them will spawn a HTTP request. And when the HTTP request comes back, it will be the function that is passed here on viewer, on owner, are going to be called. This is a bad way of doing things because here you have 4 HTTP requests that are going in parallel, like probably only 2 or 3 of them are going in parallel, the other one is going to be waiting. That's a very bad way of doing things. The right way of doing things is to use batching. So in the new 0.9 API, you can say batch equal OpenSocial API new batch. And then you add these requests, get viewer friends, get owner friends in there. And once you have added all these requests, you pass the first parameter to add is a key. And it's a key to a hash map for the request object. The request is going to be sent when you do execute on data. The request is going to be sent to the server. Server will execute all these requests and then send you back a response object that will have the specific responses for each of these calls into a hash map with the same keys. So when we're using batching, from the naive implementation that had 2 OpenSocial requests, we go to 1. And we had 4 quarter-mile API requests, we go to 1 as well. So batching really reduces the number of requests. So this is the effect of batching. So we have less requests, we have a slightly better score. And especially what's important is that we're reducing the cost in terms of bandwidth. Then there's another technique that you can use, which is part of OpenSocial 0.9. That's really new, and I really advise you to take a look at that. You can play with OpenSocial 0.9 in the Orkut sandbox and in the Shindig reference implementation. So you can check out Shindig, build it, and have it work on your local machine. I think Mr. Tanaka this morning, the developer who made all the demos, did some great demos in Partusa. That was the PHP implementation of Shindig. It's a great way to develop your stuff. And what he demoed as well is that you can have the Java version of Shindig running inside of Eclipse, and so you develop everything locally. And if you take the latest version of Shindig, you'll have OpenSocial 0.9, and you can start playing with these features. So the goal of 0.9 was to reduce the back and forth between client and server and container and your app server. So having less arrows in these graphs. So there are two techniques here, which is data pipelining and proxied content. So the way it works is that in your application, you are going to specify declaratively what kind of data your application needs. And then you're going to say, for the rendering of my gadget, you're going to go to my server. But because you have specified all the data that you wanted, the OpenSocial container is going to post all that social, is going to go to his database, get all your friends, the viewer friends, the owner friends, and everything that you specified, grab all that, put that under keys into a post message, is going to post all that to your app server. Then on your app server, you use your favorite framework, whether in Python, Java, or PHP, to render the page. You send that page back to the container, which serves it to the client. So this is what it looks like. So here I'm in the module prefs. So we have the module pref that we defined here. And in the content, I say, this is type HTML. The view is profile. And for this profile view of type HTML, the content will be on my server in a PHP script. That's this PHP script that I want to show in the profile view for my app. And it's going to be signed, the authentication. And then I say, for that view, I want the viewer request, the owner request, and I want the field's ID and display name. I want a people request for the owner friends. For user ID owner and group ID self. And these are the owner friends. So I put all these in these keys. And the result of that, when I specify all this, is that when I'm going to go to the view, to the profile view for my web application, mysite.com/proxy.php, which you can see the code for it here, I'm going to get a post from the OpenSocial server that contains a JSON data structure with the same keys that I specified above, so I can decode that using JSON decode there. And then I can just go into this post data under the keys, so here viewer data, and I know that there is a name in there, and I can display that in my HTML or loop through that. So essentially, in one shot, I get in my backend server all the data, social data that I need for my application. So when you do data pipelining, so when you do data pipelining, you get lots of improvement from that. So a significant cost reduction here, and as well as a pretty good latency reduction. Another aspect is the invalidation pattern. So when the state changes on the application server, you can make some REST calls from your server side to invalidate some application data per user or URL. So this looks like this. So here I'm going to make a call to API REST cache. So the server to which I'm making call may be sandbox.orkut.com or sandbox.mixi.com/API REST cache invalidate. And here are the invalidation keys I'm using there. I'm going to accelerate because time is flying. In terms of data store structuring, depending on which kind of backend you're using, just make sure that you're careful with your joins. When you're doing joins against friends list, if you're using a RDBMS, usually it's pretty expensive. If you're not using App Engine, which has a big table, which is a kind of optimized storage for scalable web applications, think about your master-slave architecture, especially if you're using MySQL, for example, how you partition your database. In any case, whatever technology you're using, just be sure to use Memcache to cache the data. In App Engine, you can use Memcache too. And instead of serializing the data into a native language data structure and deserializing it every time you go to the database, one best practice is just to store the JSON in there. Just have some text fields and you store JSON in there and you just put it in, get it out, and just parse it when you need it. Another best practice is that for some things, it's good to use background processing. So for things that don't need to be immediately available to the user, just have a cron job. Just do some background processing on these and create some entries in a table. And when they are available, you show them to the user. In App Engine, you can do that. Enforcing hard limit upfront. Think about the limits of your application right at the beginning when you're designing it. So, for example, when Arne built his application, he decided that friends queries was really too expensive. So Orkut lets you have 1,000 friends. MySpace lets you have as many friends as you want. There are tons of them. But the issue is, do 100,000 friends need to see your exercises, like your runs and bikings and all that? So that's when thinking about this constraint that he had this idea of creating these teams. And actually, this idea was pretty good because when you want to invite your friends to a team, it kind of forces you to choose some friends that you're going to invite to the application, and that drives adoption. So thinking creatively about the constraint can booster your creativity and can be actually pretty good for the application. So then the next decision when he decided to make the teams is how many people will I put in terms of limit per team. So in App Engine, the technology used for his backend, there's a limit of 1,000 entries per query. And there's approximately 1 entry per workout, 3 per day for 20 weeks. So that ends up being a limit of 50 users per team. Doing that work up front, just enforcing the limit and saying to users, OK, you cannot have more than 50 people in your team, is much better than having your app crash and burn and having a bad user experience and enforcing the limits afterwards. So think about that aspect initially. Now, there are some aspects where you can break the limits, but then you see that you do that stuff in an asynchronous way. So usually you put a cron job out there that does some costly processing, and these data are not available as often and as timely. So where do you put the data? You have essentially these 3 layers: your database, Memcache, and then OpenSocial app data. So Arne says that app data is one of the most misunderstood and misused portions of the OpenSocial specification. So let me tell you how you can use it. So app data, you can store key value pairs in there. But the thing is, it's quite public, so you cannot put secrets in there. It's user writable via JavaScript, so you can't really trust it, but it's really fast. So it's a great place to store some slow data. And then you can have a background process that does some slow calculation on the server side. When it's finished, it's using the REST API to populate the app data. And then when your gadget is rendered, it just can get access to the app data directly. There's no server hit. Now, container mandated optimization. Some container, for a container, if your app is really slow, it's a bad experience for their users. So they want to they want to keep developers, they want to encourage developers to create fast apps. In the directory that for all applications, for example, in iGoogle, the directory will soon be taking latency into account. Yeah, so here you can see an example of some gadgets that are really slower than others. So the directory will kind of sort gadgets based on latency. An example of container-mandated optimization is Orkut template-only profiles. So profiles are the most traffic on Orkut, which is Google's social network. And in OpenSocial 0.9, there's this notion of templates where there's no JavaScript code. You can display social data and app data, and it's all executed by the container. So there's no external fetches or dynamic data, and it's very fast profile experience. So that's what calling it looks like. You say require feature OpenSocial data and templates. Then you say, I want this template to be processed on the server, and then you provide the template there. You say, oh, I want the friends for the viewer, and then here's a template. You say this is a type text-to-OS template, and then there's a templating language where you can do loops and things like that to do the display. So in summary, I'm sure you must be even more tired than when you entered in here because there's a lot to assimilate here. But these are a bunch of techniques to minimize your app size, your number of requests, and your latency. And this is really something to consider when you're building your app. For quite a while, the source code is out there. There's a naive implementation and an optimized implementation. What you gain there is that there's a delta of 1.6 millisecond in latency for the gadget, and 0.6 second for the latency of the whole page. So that's a pretty big gain. There's much less request, a much better Y-slow score. And we're kind of cutting $325 out of our monthly bill for this application. So thanks to the better speed, we'll get more users, and thanks to the lower cost, we get more profits. So that's all good for you. Now, I wanted to conclude on performance Satori. So that's another story of the same Joshu with his Chinese name here. So one of his disciples just asked him, have you eaten your meal? And the monk replied, yes, I have. And Joshu told him, then go wash your bowl. And at that moment, the monk reached Satori. So I hope that after all I told you about all the stuff that you need to do to your web application, you'll just go back home reaching performance Satori for your web applications. One last thing I wanted to tell you about is just last week, Google released PageSpeed, which is a Firefox extension that has some of the features of Y-Slow, and it's really good. It gives you lots of indication about how to optimize your page. Actually, this is a great example. This extension is an open source project. It's hosted on code.google.com. And when you open the extension on the page of the extension, you see that they have an advice saying leverage browser caching. So even the Google engineer who coded that extension haven't optimized their page completely. There's always more work to be done to optimize your application, and there's always more of the rice to wash from your bowl. Google Developer Japan has a page about Google Developer Day that you can find there. Code.google.com, there's a Japanese page that allows you to get further with all these techniques. That's it. Do you have any questions, or do we have some time for questions? Yes? Oops, let me put that in.
Yes. I would like to know the name of the book you were mentioning.
Yeah, so the book I was mentioning is Steve Souders, high-performance websites. And I recommend you to go to the videos for Google I/O, because he gave a great session kind of summarizing all that. So that's this one. So high-performance websites and even faster websites. I think he's working on a new version of it. But this is essentially most of the kind of general advice that's part of this talk come from Steve's learning. It's a great
Thank you.
book. Yes?
Thank you for a great presentation. I have one question. Do you have some information about improving performance, OpenSocial specific way to improve performance on 0.8?
So in 0.8, as part of the tips that were part of the presentation, you want to use at least batching. You want to batch your requests.
Batching, yeah.
Yeah. So that's one of the tips that's applicable for 0.8. The fact of using app data is also very relevant to 0.8, because 0.8 introduced the REST API. So if you have some really costly operations on the server side, you do your costly operation as a cron job on the server side, then you fill the app data with all the data, and then your application on the client side can get the app data. Essentially, you use app data as your local cache inside of the container. So these are two of the ones that are very relevant even to 0.8. You don't need to wait for 0.9 to use that.
Thank you.
Yeah, because Mixi hasn't implemented 0.9 yet. So for people who want to build applications on Mixi, at least if you apply all these tips that are presented in the presentation, you're in a pretty good shape. You should be in a better shape. Any other question? Oh, okay, sorry, it's finished. Thank you very much for coming, and hey, have fun coding your applications.